Okay everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering. Let's start the session. I will solve our SI number second and give you some suggestion of for assignment number 3 also. They are given a question number first. Okay, I will share in last today. One second. You can see there. Okay, question number first is given. Capacitive inductive load when connected to the BJT causes abnormal switching transient during. Everyone know about the capacitor and inductor. Capacitor does not allow the sudden change in voltage, and the inductor does not allow the sudden change in current. Then when turn on the switches, it means in rise time, currents charge, currents flow. That is the current change from 0 to some. That is switching transient occurs on inductive load, and fault times voltages occurs, that is capacitive load. It means the both rise and fall time, both switching occurs when inductive or capacitive load presented in the load. Then E option is correct for both rise time and fall time because of the inductive and capacitive load. In both conditions, the voltage and current will change. This one is option is correct. Question number second given. NPN PGT carries collector current 200 milliampere and beta is given 100. Base resistance also given of 500 ohm and VB is 0.6 volt. Then is asking about the VBB voltage. Here RC is given 500 ohms. Oh, sorry. RB is given 500 volts, 500 ohm. VB is given this one voltage 0.6 volt. And IC current is given 200 milliampere. Beta is 100. In NPN transistor, I is equal to IC plus IB for the transistor, and you know about the IB is equal to IC by beta. When you solve the BGT questions, you should put the current in milliampere, and put a resistance in kilo. Then you will find voltage in volt only. For the easy calculation, you can do this. So for any questions related to the BGT, you should take this notation. It means IC is written like a 200 milliampere. Okay, and RB is I written 0.5 kilo like that. You know about the IC is given 200 milliampere. Then IB is equal to IC divided by beta. Beta is given 200. It means 2 milliampere. Hence, you know about IB, you can use a KVL in this loop. Apply KVL. You find minus VBB plus IB into RB plus VBE is equal to 0. Minus VB is not given. You should find VBB is equal to IB into RB plus VBE. IB is 2 milliampere, RB in kilo ohm 0.5 plus VBE given 0.6 volt, and we find easily the VBB is 1.6 volt. We should take I is in milliampere, resistance in kilo ohm. Then we find all of things easily. Calculation also easy. Next question is given like NPN BGT as beta is given 100, base resistance is given 500 ohm, load resistance is given RC 30 ohm, VB also given 0.6, VB is 5 volt, and VC is given 10 volt. The BGT carries a collector current IC 200 milliampere. In the same question, I added the VB here, VEE. You find asking about the VCE. VCE means this voltage. If you want to find this voltage, you should know the all of should apply the KVL in this loop. This VCC like this one ground, and VCC is given like that, and this ground is here connected between it. You can apply a KVL like that. In this you should know value of IC, RC is given, find the IC also given, RC is given, VEE is not given. Then first find VE voltage, after that apply to this loop KVL. For finding this VE, you apply loop second, written like a loop 1, this one loop second KVL. In this you should have a IV, but IV also not given, and find IV. First find IV. RB is given, I written here 0.5 kilo ohm, IC given 200 milliampere, RC given 30 ohm. 3 kilo ohm. You can write it like that. Same thing apply. IC is given 200 milliampere. Then IB is equal to IC divided by beta 2 milliampere. This voltage 0.6 volts is given VBE. Apply KVL here. Then we find minus VBB plus IB into RB plus VBE plus VEE is equal to 0. We require a VEE, then find VEE, VBB, minus IBRB minus VBE. VBB is given a 5 volt, IB is given like 2 milliampere into 0.5 kilo ohm. Will be 0.6 volt. Then we find 3.5, 3.4 volt. Once you find VE, apply the voltage KVL here in loop first. Then you find VCC. I written here. You can written like minus VCC plus IC into RC plus VCE plus VEE is equal to 0. You required VEE. VEE is equal to VCC minus IC into RC minus VC. Sorry, we required a VCE voltage minus VE. You know all about value. VCC is given like 10 volt minus IC 200 milliampere into 0.03 kilo ohm minus V 3.4 volt. Find I think 0.6 volt VCE. Question number 3. Question number 4 is given like when the following figure, how should be the maximum value of RB? This well resistance is asking about this resistance. So that BGT operating saturation region. BGT parameters is given beta ranges like 10 to 50. VCE saturation given 0.5 volt. VE saturation also given 0.8 volt. And VCC is given 100.5 volt. RC given 25 ohm. 25 ohm you written like 0.025 ohm kilo ohm. Sorry. VB given 10 volt, VB saturation is given 0.8 volt and VC saturation is given 0.5 volt. Is given the maximum value of RB, asking about the maximum value of RB, so that BJT is goes in the saturation region, operating saturation region. It means this BJT must be operated in the saturation region. Then what is the value of RB? When the beta I changes from 10 to 50. Then in saturation region, VC is given like VC saturation is also given 0.5 volt. Then you usually find the IC current saturation. Here, first of all, apply the KVL.
But VC is 0.2 can be taken, sir.
Sorry?
VC is at 0.2 can be taken.
No, is given. VC saturation is given 0.5 volt. Then you can't take 0.2 volt. If if they are not given, then you can.
But VC is 0.2 can be taken, sir. VC is at 0.2 can be taken.
I written a KVL. VCC is equal to IC into RC plus VC. All is the saturation value. This is given 100.5 IC and to find RC is given 0.02 volt, 25 volt, 25 kilo ohm. VC is given 0.5 volt. Then find IC. 100.5 minus 0.5 divide 0.025. I think this one is 4,000 milliampere, or IC is 4 ampere. You know about the beta saturation is less than the beta value, but a question is given beta is ranges from 10 to 50. Then for ensure the saturation region, you should take a beta as a minimum value. The minimum value is given at 10. Then take this one, 10 value is the beta value is a 10. Then you find the IB. IB is equal to IC by beta minimum. IC is given 4 divided by 10, 0.4 ampere. And IB saturation value should be greater than or equal to IB. It means 0.4 volt, 4 ampere. IB is given here. Can apply KVL in this loop. VB is equal to IB into RB plus VB. All of the saturation value, the VB saturation is given like 0.8 volt. We'll take this one, 10 is equal to IB. RB is given, think RB is asking about that. Sorry. RB 8 volt. Then IB, find from here 9.2 divided by IV. This one IP saturation, because if you take all the value is saturated value, then you say that this one is saturated IV current. So also saturated value. Then IV saturation should be greater than the IV current. Then you return on 9.2. So RV, sorry, then 0.4. RV should be less than or equal to 9.2, 0.4 equal to approximately 23 ohm. He asked about the maximum value of RV. Maximum value of RV is 23 ohm. You can.
Sir, I have a question, sir.
Yeah. Oh, ask.
So, because beta is range from 10 to 50, so why should I not take that 50, sir?
Because our beta
Because if I take
in saturation condition, beta should be lesser than the beta saturation should be
Sir,
lesser
I have
than
a
the
question,
beta
sir.
in all of condition. Here given
So,
the ensure
because
the
beta is
saturation
range
region.
from
This is
10
beta
to
is the 10 to 50.
50, so
Then
why
you
should
take
I not
at
take
least
that 50, sir?
10 or less than 10.
Because if I
Is
take
the
50,
beta saturation.
I confused about this one, sir. I consider 50, sir, beta. That's why my resistance comes to 115 ohm, sir. Sir, this question asking maximum value of the resistance. If I
Yeah.
consider, sir, 50, sir.
If you consider 50 and beta ranges some other you can take, then
I confused about this one,
you
sir.
apply
I
all of
consider
value
50,
to
sir,
find
beta.
I
That's
think you
why
find like
my resistance
this
comes to
BJT
115
is not
ohm,
a
sir.
saturation region.
Sir,
It's
this
given
question asking
goes and cut
maximum
off region
value
or
of the
equal region.
resistance. If I consider, sir, 50, sir.
For ensure the value, ensure the situation.
Sir, if I consider 50, sir, beta, then definitely it will go saturation, sir, because it says that its range varies from 10 to 50.
Then in beta saturation condition, में beta
if I
saturation
consider,
is less than
sir,
the beta,
if I
beta
consider,
value. But beta is given 10 to 50.
if I
You
consider
can take a beta
50,
like
sir,
a
beta,
50,
then definitely it will go
you can take
saturation, sir, because
as
it
less
says
than
that
as
its range varies from 10 to 50.
As a least value of beta. Beta is given 10 means you should 10 is the maximum value of beta. You can't take more than 10. Because the beta saturation is saturation less than the beta value in saturation condition.
But it's a given that a little bit confused about this one, sir. Because what I did, sir, I consider first beta 10 and then 50. So then I
But
see
it's a
that
given,
for
sir,
10
that
it's a 23 ohm, for beta 50 it's a 115 ohm. And the question is asking that maximum value
but
of the
it's a
resistance.
given that
So if I consider
a
50,
little bit
sir,
confused about
115
this
ohm,
one,
sir,
sir. Because
then
what
also
I
current
did,
will
sir, I consider first beta 10 and then 50. So then I see that for 10 it's a 23
Okay,
ohm,
you
for
can
beta
take
50 it's a
if you take
115 ohm.
50 as the
And
beta
the
value,
question is asking that maximum
then
value
is
of the
given the
resistance.
maximum value of RB
So
is
if I consider 50,
150.
sir, 115 ohm, sir,
115.
then also current will
If I
it goes to
consider
saturate,
115
sir.
ohm RB, sir, definitely, sir, that IC current will 4 ampere, sir. Sir. If I consider, sir, 115 and beta is 50, definitely, sir, IC
115,
current
sir.
will flow 4
If
ampere.
I consider 115 ohm
So it's in
RB, sir,
saturation
definitely,
condition.
sir, that IC current will 4 ampere, sir. Point.
For the plan, find a value of IV.
If I consider, sir, 115 and beta is 50,
and
so
IV
definitely,
value.
sir, IC
And
current will flow 4
compare between
ampere.
them. What is
Question
the
is that
difference? Question
it's
is
in
given a
saturation
maximum
condition,
value,
sir.
but here one problem here. if you take a 50 as a beta value, then in some condition it will go beyond the saturation region.
The question is that maximum value of resistance.
If you solve up the thing, you find the IV value and another thing, then you find the so BJT can go to
because it's a given, sir.
Another region. That's why you can take a 50 at the maximum value. You should take as minimum as possible.
But none of the lectures are discuss about this one, that which beta you have to consider.
No, can I
Actually
say
here,
worst possible case, beta is ensured that 10 means 100% in 10 when
but
beta
none
is
of the
10,
lectures are discuss about this one,
10
that
is-
which
10 is
beta
the
you have
value
to
where
consider.
it will definitely go
No,
into
can I
Actually
say
here,
50 is a value also, it may go into saturation.
worst
But
possible
worst
case,
beta
beta is ensured that 10
10
means 100%
That is why we
in
have to take
10.
10.
When beta is 10,
No,
it
why-
has to
why
go
10?
to
Why not
saturation.
50?
The 10 is the value
because
where
the
it
lower
will
the
definitely
beta,
go
we
into
guarantee
saturation,
that
and
in
50 is a
beta,
value
if
also.
they
It will
by
it
data
may
sheet
go
they
into
are saying
saturation.
that it is
But
10
worst
to
case
50
beta is
it means that
10.
if the gain is
That
10,
is why we have to
it
take
will
10.
act
No,
in
why
saturation.
10?
Okay.
Why not 50?
In
Worst
50,
case.
it may or may not.
Because
It
the
may
lower
also-
the
in
beta,
50 also
we
it will
guarantee
go
that
into saturation.
in beta,
But
if
worst
they are
and
by
10
data
is a
sheet, they are
ensured
saying that
parameter.
it is 10
That
to
is,
50.
the lower the
Is
value,
it means
will
that
go
if the gain is 10,
in
it
lower
will
value.
act in
That is why
saturation.
I
you-
Okay.
got that thing.
In 50,
No, but as
it
per
may
the
or may
question,
not.
maximum how
It
much
is also in
RB
50
we
also
can
it will
consider.
go into saturation. But worst
that's
and
why we
10
have to
is an
consider,
ensured parameter.
50
That
beta.
is, the lower the
Because here
value,
if
it
it's
will
a
go in
150 ohm
saturation.
resistance, if I connect,
In
definitely
lower value also.
collector current flow.
That is why you
I
have
got that thing. No, but as per the question, maximum how much RB we can consider. It's not mentioning that when it will. So that's why we have to consider 50 beta.
It is more
Because
important
here
part
if it's
here.
a 150 ohm
you
resistance,
should
if I
ensure
connect,
that
definitely
the BJT should
collector current
operate
flow
in
that
the
4 ampere.
saturation region. In any
As
other
per this
any condition,
question,
it cannot
question
go
is not
beyond the
mentioning
saturation
that
region.
when it will go
If you take a
saturation
beta
or
as a
not.
50, then in some condition RB is great. If you take a more than 23 ohm like that, 100 ohm and beta is not 50, some other I think 20 or 30 like that. If you take like that, then BJT gone beyond the saturation region. You go either at the cutoff region or active region. Also give. Because that's why we will take 10 as the maximum beta value.
We have to take 10 as a max value under consideration, and that RB is also limiting factor at that time.
Yeah.
That is that if we exceed 23, then also it will go out of saturation.
Why, sir? How
We have to
I
take
can
10 as
understand
a
this?
max
10
value
as per this
under
question.
consideration, and that
If you put
RB is also
24
limiting factor at
and the
that
gain
time.
is 10,
That is
it
that
will come out
if
of
we
saturation.
exceed
That
23,
is why maximum
then
value is
also it will
23
go
for beta
out of
when beta is
saturation.
10.
So, but why, sir? How I can understand this one then?
10
As per
if,
this question.
Okay, but we have to take
if
the
you put
worst
24
case, that is 10.
and the gain is 10,
But in
it
design
will
also
come out
we
of
have to take
saturation.
10, no?
That is why
That
maximum value is
it is
23
given that
for beta
is
when
10,
beta is
10
10.
to 50, but we have to take 10 only.
So, but this question is saying that it ranges from 10 to 50. If I again consider 50.
Okay,
then
but we
resistance
have to take the
maximum.
worst case, that is 10.
नहीं है उसकी. Beta
But
की
in
range
design
नहीं है.
also we have to take 10.
Designer
No?
has to take
That is
one case.
that is given that beta is 10 to 50, but
You
we have
take
to
any
take
beta.
10 only.
Data
50,
sheet में आप
sir,
देखोगे ना,
50 is the worst
find
case,
the
sir.
beta range.
If I
That
again
is from,
consider 50,
10
then
to
resistance
15,
But it's
maximum.
not guarantee
to
नहीं
200.
है
But
उसकी.
we have to take
Beta की
worst,
range दी है आपको. Designer has to take worst
corner
case.
of that beta.
You take
अगर
any
मैं I'm not
data sheet
much
में आप
convinced
देखोगे ना,
because
तो
I have
you will
never
find the
studied
beta
like
range
that.
that is from
Question also not
10
saying
to
anything
15, somewhere it would be 100 to
design
200,
parameter,
but we have to take
conservative
worst
figures. Because we cannot design
corner of that beta.
the beta at 50, not at all.
Okay, I'm not
Okay, you can-
much
you-
so
you-
convinced because
you
I
can
have
check
never
like
studied
that.
like that.
Question
take a
also
voltage
not
of
saying
here.
anything about
Find the
Nahi,
voltage.
it
saturated
is
voltage
design
here,
parameter. We have to
like
take conservative figures
this one,
because we
100 volt
cannot
minus
design
this IC
this
into
circuit
RC,
with the beta
and
50,
find
not
out
at
some
all.
voltage here. And
Sir, what is
this one the
saturation
NPN
region?
transaction
What is saturation?
transistor, and this one is the forward bias. So okay, for the saturation region you should have this one also in forward bias condition. Both junction is forward bias, then you can say that this one is the saturation region. But you check the for different beta value and different RB value, you can check for one side, then you find like that.
Okay, sir. Oh. Okay, sir. You continue, sir.
Sir, what is saturation region? Can you define?
Saturation means that both are junction in forward bias.
That means IC is maximum, right?
Yes, sir.
Yes.
IC is maximum.
Okay, sir.
Yes.
Oh.
And IC is maximum. means
Okay,
IC
sir. You
will be
continue,
beta
sir.
times IB. Sir, what is saturation
Beta is
region?
50.
Can you define? Then IC will be maximum in saturation.
Yeah.
That means IC is maximum, right?
Yes.
IC is maximum.
Yes. Yes.
Is that correct? And IC is maximum means IC is equal to beta times IB. So if beta is 50, then IC will be maximum in saturation.
Excuse me, sir.
Yeah.
So will you upload this video on your YouTube channel?
Yeah. I can.
Is that
Okay,
correct?
sir. Thank you.
After this,
Okay, sir.
can we discuss later here?
Sir, you will discuss later.
Okay.
Excuse me, sir.
You can discuss later.
So will you upload this video on your YouTube channel? Okay, sir.
For
Thank
NPN
you.
transition, the next question.
Okay,
in the
sir.
transistors, which one is true? The base driver source should have a sinking capability
Sir,
so
you
that
will
the
discuss
negative base
later.
current can flow.
You can discuss later.
Another is given in saturation region, VC is greater than VB. This was not possible. VC always less than the VB in saturation region. The VC is ranges at 0.1 to 0.2 in some condition is greater, and VB 0.6 to 0.8. The collector to emitter leakage current flows only when VT is on. Leakage current flow in both condition, in VT on or off. That's why is say leakage current. Then this one is the true and all of the false.
Sir,
Yeah.
I am not getting the base driver when VB is making the circuit first base to emitter junction forward bias. At that time, the source, that VB source, is going to supply the current. Na? So how the
Sir,
VB is going to sink the capacity? I am not getting the base
Sinking
driver
is,
when VB is
electrons.
making the circuit first base to emitter junction forward bias.
Yeah.
That time the source, that VB source is going to supply the current.
base
Na?
to emitter.
So how the VB is going to sink the capacity? So here how the source of the base junction is going to sink capability. So but that from base to emitter. So here I can current is flowing in that way, na? From battery also, from the base to him. Okay.
Negative base
So
current
here how the
here
source
is a
of the base
sinking capability of
junction
electron
is going
not
to
the
sink
current, there's
capability
negative
so
is
that
positive
negative
base
base current can.
Yeah.
So here I cannot
Yeah, it is
understand the
positive
negative base
base
current.
current.
This is actually it is forward base current. No?
Yeah, this one is some. Yeah.
We are confused actually.
Yeah.
Base
current. Wrong.
Sinking capability of electrons, so that positive base
Yeah,
current.
yeah.
Sinking current, sinking capability of electron.
Sorry,
Okay, that is
okay.
isn't positive current. It has to be positive base current. We are confused actually. Thank you, sir. Positive base current.
Next question.
Sinking capability of
BJT.
electrons, so that positive base current. Sir, will you get the mark for that? So
yeah,
that is why it is. Isn't it?
Voltage control device.
Thank you,
is
sir.
not a voltage control device.
It is current
current control device. Unipolar
Sir, will
voltage
you get the
device.
mark for that?
How it is unipolar voltage device? They are
Okay, thank
telling that this is also correct. Unipolar
Unipolar,
voltage device.
unipolar means you can apply a negative voltage. If you apply a negative voltage, this one is not
It is current
functioning.
control.
That's why given like a unipolar. This one
How it
bipolar
is
also,
unipolar
correct.
voltage device?
Charge
They are
carrier.
just telling that this is also correct. Unipolar
Negative temperature
voltage
coefficient, yeah. Because of p-n junction. Positive note.
Here it means that third option, that unipolar voltage device.
Yeah.
When we supply positive base current, it will act as an forward saturation region or conduction region, active region, whatever. But if we apply negative base voltage, here it means that third option, that unipolar voltage device. When we supply positive base current, it will
Is it like that?
act as an forward saturation region or conduction region, active region, whatever it is. But if we apply negative base voltage or negative current drive, then it will block the device, will block the voltage or current rather in secondary
base
side.
current required
Is
to
it like
drive
that?
the transistor.
Yeah.
Beta is given 45. 10 resistors connected series with the collector terminal. This one is a collector. This one base. This one emitter. This is connected 10 ohm RC. This one IC. Is given a terminal dissipated of 2.5 watt. IC square into RC is equal to 2.5 watt given, and find the current of IC 2.5 divided by RC. RC is 10 ohm. Take under root of this. Find 0.5 ampere. Then find IB. IC divided by IB beta. Equal to milliampere. I think 1.1 milliampere.
Actually, I made little bit mistake to this question. Actually, I got that answer 0.011 ampere, but I didn't notice that it's asking in milliampere. That's why my answer got wrong, sir. I didn't notice that it's asking milliampere.
Yeah, this one is
actually, I made little bit mistake to this question. Actually, I got that answer 0.011 ampere, but I didn't notice that it's asking in milliampere. That's why my
question number
answer
7, the transistor emitter is
wrong,
grounded
sir.
and the collector resistance is connected to the 50
I didn't
volt.
notice that it's asking milliampere.
In the same question.
Yeah. Okay.
This one is given 15 volt. Emitter terminal the grounded. Collector resistance is connected to the RC. Conduction loss in transistor. IC you find out from previous values.
One thing I want to say that in our question it's referring to question number 2, sir. That's why I didn't get the answer. If you see the that assignment, there it's written referring to question 2, sir. That's why I didn't get the answer.
Sir, yes, same
Sir,
thing.
one thing I want to
Referring
say that
question 2.
in our
And we
question
got
it's
the answer
referring to
different
question number 2, sir. That's why I didn't get the answer.
and
Can't
whatever you are
see the
solving now
sir
with
that
the reference
assignment.
sir, questions
There
1,
it's
2
written referring to question 2,
Yeah,
sir. That's why I didn't
then
get the answer.
answer also will same.
Sir,
Don't you?
yes,
If
same
you
thing.
given the 2,
Referring
then
to
the
question 2.
answer
And we got the answer different than
take it
whatever.
the question number 2.
Huh,
It will not
That's
take
why I
it.
can't
whatever you are
calculate.
solving now with the reference number question
But
7,
question
it
number
will
two is
answer
the
will be
second,
different.
I think. The another you can mail. In this one is the different circuit. You can take it this one.
This is different.
Different circuit.
Sir, I already mailed, sir. I mailed.
But we have
Mailed,
got,
sir.
Yeah.
Already
we
I
have got
mailed that
the
that's why I
answer,
could not
this thing,
means,
marks for that.
wrong answer. That answer. I mailed already.
Marks.
Then
We cannot Yes, get the it is- right answer. We have not reached the answer. It is confusing. This is different. If you
Sir,
consider.
I already mailed, sir. I mailed.
Okay, we
I
Mailed,
think
sir. Already I mailed that.
I
That's
think
why I
you
could not means
mail
derive that answer, sir.
okay.
I mailed already.
We
they
cannot
can,
get the right
justify
answer.
you
We have not reached the
later.
answer.
Yeah,
It is
yeah,
confusing.
they provide you all of
If you consider
then
second as a
marks to all.
Okay, we discuss that 7 and okay.
I
Okay.
say it's same 0.5 ampere. Beta is same 45.
Marks.
In IGB in BGT conduction loss is IC into VC. This one voltage. For find the VC value, apply the KVL here. 15 is equal to IC into RC is VC. Then find VC value 10 volt. And find conduction loss 2.5 into 10.
Yes, sir. That's why if we consider referring question number 2, then
Yeah.
there is no RC value. That's why we couldn't find out the VC value.
Okay.
We consider referring to question 2, there is no RC value. Yes, sir. That's why if we consider referring question number 2, then there is no RC value. That's why we couldn't find out the VC value. Twice, sir. If
I think this
we
one question
consider
number
referring to question
another
2,
question
there is
is
no
given,
RC
sir.
value, sir.
This one. There is also not given. RC is given.
If you check, sir, to question number 2,
There is no RC value. Yes.
no
This one-
RC
this one
value.
is
So
the
that's
same
why I
question.
confused, sir.
What RC
I
we have
mailed
taken for our discussion
twice,
now?
sir.
For question 8.
You can take 30 ohm from
30 ohm.
question number 3, but I think they do some
This is
mistake.
given 30 ohm.
They want to provide a question number reference question number 6,
So-
but by mistakenly
What RC we have taken for our
given
discussion
the
now?
question number reference
For
of
question 8.
So for the question number 6, that is
30 ohm.
BJT is a unipolar device, a unipolar voltage device. Unipolar means that is, give some explanation, sir. Unipolar voltage device.
Unipolar voltage means you can apply only
Positive or
positive voltage apply. You
Sir,
can
for the
apply
question number
negative.
6, that is BJT is a unipolar device, a unipolar voltage device. Unipolar means that is,
negative voltage.
give some explanation, sir. Unipolar voltage device. So either it may be a unipolar voltage device. You can say like positive or positive.
Mention a
only,
voltage
sir.
device.
Positive only.
Not a junction voltage.
So we can apply positive only, sir. We didn't apply the negative voltage to the BJT. It's not possible.
You want to identical
Okay,
BJT
so
with
either it may be a
additional
unipolar
resistance
voltage device.
given.
We can say like this, unipolar voltage device.
These
Okay,
two
okay.
R1
Okay,
R2
okay,
connected
okay,
in the
okay.
parallel
Understood.
and is supplied through a constant current source. Is given. This one I think given 1 ampere. With the R1 plus R2. Okay, VB1 plus and VB is given V1 minus VB2 is given 0.02 volt. This is not the same value, this one different for the both. And IC also VB is also given 5 volt, and IC is current given. You find IC1, then you would take ISS into e की power VB1 divided by n VT. N is given 1, VT 25 millivolt, and ISS is also given. Same thing. If question number first, IC2 is ISS e to power VB2 divided by NVT. I think you can divide both equations. Let's go first to second. Then you find IC1. ISS cancel out. E to power VBE1 NVT divided by e की power VBE1. You can take n is equal to 1 and VT minus VBE2 e to power VBE1 minus VBE2 divided by VT. You can solve, all of the values given, e to power 0.02, 2.225. Question number third. And here is given the current, constant current 1 ampere is the same IC1 and IC2 plus IC2. IC1 plus IC2 is equal to 1 ampere. You can solve this one. And IC1 is 2.225 IC2 plus IC2 and IC1 6.9. IC1 and IC2 find. So then is given a VB and VB2. For finding the R1 value, R1, R2, you should find the VBE1 value, this one value. Once you find it, then we can apply. You take a natural log here of the book. I will it in here. This one eyes. you can find this one value, multiply Vt 0.7966. Same thing apply for the Vb2. Once you find Vb1, Vb2 value, you apply this KVL here. This one. In first condition, apply Vb to Vbe1 one condition also here it not mentioned beta value. If beta value is not mentioned, then you can take beta as infinity. You will take this one, then you find IC is equal to IE. IB is equal to 0.
Sir, this is a different question than assignment question, isn't it?
Yeah, it can different.
Sir, this is a different question than assignment
Try
question,
to find
isn't it?
R1. I is taken IC1. Because beta is not given, you can take beta as an infinity value. You find 6.09 ohms. Same thing apply for R2. .62 and R1 plus R2. Asking about the, you find your 9 plus 30.62, 90.7 ohms.
Sir,
Oh, yes.
You are taking beta equal to infinity.
Yeah. Beta is not given actually in the questions. Then you can take a beta as a infinity value. If beta is mentioned here, then you can take a beta value.
Is it always like that, sir?
If the beta value is not mentioned in the question, then you
You are
always take
taking
a beta
beta
as
equal to
infinity.
infinity.
If a situation also not given, not given at the transistor in saturation region also not given, then you can take beta as infinity.
Is it always like that, sir? Which means that B is 0.
Yeah.
IB is 0.
Yeah, IB is 0, IC is equal to IE.
Oh.
The same question is given the mountain in the
Which
surface.
means that B is 0.
Same heat sink.
Which means that IB is 0.
And is given the T1 junction temperature is given in the first transistor is a 60 degrees centigrade and ambient temperature is given 25 degrees centigrade. It is asking about the heat sink to ambient thermal resistance. We realize like that this one I think to take this one junction J1 and this one a case C1, same thing is for a second, this one junction J2 C2 and both are mounted in the same surface, heat sink, and sink is the same, and ambient temperature for the both is same, like that. Here the thermal resistance is added. This one is given the heat sink is temperature same throughout the heat sink. It means all of the thermal resistance is the same, not this point. That's why you look at written as a you can written draw a diagram like junction temperature J1 and junction temperature J2, adding some thermal resistance like thermal resistance of junction to case and the thermal resistance of case to heat sink. Same thing here also. This one mounted on the same heat sink, some temperature of heat sink, thermal temperature of heat sink to ambient. This one temperature of ambient. Temperature difference between 2 point like that. This one the power P1, like power P2. For find temperature, first to find the power. Know about the is given power saturation voltage is given VC 0.6 volt and 0.5 volt for the second. Then know about the power is IC and into VCO. IC1 0.69 ampere and VC1 0.6 volt and 414 watt. P2 0.58. So find the P1 and P2. After the applied here, junction temperature J1 minus heat sink divided by this one thermal resistance JC is equal to P1, and you can take here like a P1 plus P2, then find THS minus TA divided by RTH heat sink to ambient P1 plus P2. Add this one, multiply by there, and by TJ1 minus THS plus THS minus TA, can multiply P1 RTH JC plus RTH CH plus P1 plus P2 HF. This one cancel out. Junction temperature is given, I think 60 degree, ambient again 25 degree, RTJC is given 40 and CS given 0.5. Apply here 60 minus 25, P1 is given 0.414. This one is given a 40 and 0.5 and written 40.5 for both. 414 RTH heats into ambient. You solve this, we find RTH heats into ambient 30.7 degrees centigrade per watt. Okay. I think this one is the assignment number second, I think. And here I'm trying to give you some information regarding to assignment number third. Here the value is different. I will take in a different data sheet for the MOSFET. This is not the same as your assignment. A MOSFET is operating 50 kHz switching frequency with a 0.4 duty ratio connected to a resistive load of RL is 20 ohm. Here is given 20 ohm. Voltage source is given VDD is 100 volt. VGS maximum is given 20 volt. 0 to 20. Considering the off state power is 0, find out the total power loss including both switching and conduction losses across the MOSFET. Use this one data sheet. Conduction and switches losses. Conduction losses. Let's about the conduction losses. For the conduction losses, you should have a RDS on resistance of the MOSFET. It's given from the data sheet. You can take up from the data sheet. Just give IRF P240. Is the MOSFET part number. You can search on Google. You can find the data sheet of this. And after the applied, I already talked about the power losses. Power is power calculated. If resistance is given, then you should have a RMS current, and as the voltage source is given, then you should have an average current of. Here the MOSFET or any other switches, they apply the square wave, and you can see like that.
Sir?
Yeah.
Sir, I have a doubt regarding that beta equal to infinity that you said in the previous problem to assume.
Yeah.
Sir, in that, sir, if IB is 0 and beta is infinity, sir, how can we conclude that the IC is having a finite value, sir?
In this questions.
Yes, sir.
Actually, you know about the IE is equal to IC plus IB. If IB is 0, then IE same as the IC. collector current. All of the electron go into the collector, not any electron goes into base.
Sir, but there is another relation that IC beta into IB.
Yeah, beta is infinity, na?
Yes, sir.
Then IB is 0.
Yes, then what about that is what, then how can you say that IC is having a finite value, sir? Because we don't know what is this indeterminate form, infinity into 0.
No, beta is defined from the base current, not IC, collector current.
Yes, so there is a relation that IC equal to beta.
Yeah. This one, IC is equal to beta into IB.
Yes, sir. Yes, sir. This one, that one on the left, you have written on the bottom.
Yeah.
So in that case, you are saying this beta is infinity, then IB is 0. Then the IC is an indeterminate form. So
beta is used for finding the IB value by IB value, not IC value. IC is given in the questions. Then you cannot take as a infinity or some other thing.
Yeah,
if IC is not mentioned, yeah.
Then our assumption that beta is equal to infinity is valid as well. Is it valid? That that's my doubt, sir. Because we are assuming beta equal to infinity, since its IC is given some finite value. If you go with this equation, it is becoming indeterminate form.
Yeah, but if you take as a bit IC is some other value, then you can not take a calculation also, na? If you have a take, you can take any value, na? If you can't take IC is the finite value, then you can take any value, and you find a different value, a different all of the parameters. Beta is infinity, which means it is defined as the none of the electrons go to the base. All of the electrons jump to the collector. It's the 100%. It means the 100% electron goes emitter to the collector. None of the electron goes to the base. It means the it means the 100 value. 100. It means all of the current goes to the emitter. It is not infinity. It means the 100% value. The beta is the percentage. Okay, go ahead.
Yes, sir. You can go, sir. Next question.
Okay. Thank you.
Thank you, sir.
This one is just voltage applied to the gate to source, and this is the current of ID. When gate source applied gate voltage, then it MOSFET is on and gate is off voltage, then this was it off. ID is 0. Then VDS you can say at 0, and when the MOSFET is off, then all of the values appear in the VDS and VDD value. And this is given the duty ratio. This the time period is dt. This one is the 1 minus dt. Know about that. All of this is the total time period. So dt and t. RDS is not means given. It is given in the data sheet. You can find there. And ID, you should have a ID RMS current of the drain current. For the RMS value, you and this waveform ID you can find easily.
Sir.
Yeah.
Here ID is equal to 100 volt divided by 20 ohm, that load resistance plus RDS on, or we have to take 100 volt divided by 20.
Simply take 100 volt divided by 20.
No need to take RDS.
Yeah, no need. This is the approximate value. The RDS is in milli ohm. It is not more effective. But to find the exact value for the in critical cases, if you want to find exact value of ID, then you can take as a
RDS on if the RDS is very considerable to the RL.
Yeah.
then only we will correct. Otherwise,
Then because of the RDS is in milliohm and 20 ohm is the RL, then this one is very less value.
okay. So ID RMS is equal to ID root 2. Root 2 no, it is root 4. Root 0.
Point 4.
0.4.
Yeah. ID
So,
square into dt divided by t. Yeah.
ID into root of 0.4 bracket square into RDS on, that is the conduction loss.
Yeah.
And for switching loss, it is same as VCC into ID into TR plus TF divided by 6TS, is it?
Yeah.
Same as transistor. Okay.
ID RMS 5 root D. From here, D duty ratio is given 0.4. 0.4. Then we find 3.16 ampere. We find the IDS value. IDS value is given in data sheet. IDS is given as 0.18 ohm.
1.8 ohm.
You can take 0.18 ohm.
So,
P conduction. Square. What? What are switching losses? You can observe the waveform of on and off duration, then you find like that.
yes.
Take a look at the voltage. This one on time.
So for the peak conduction loss expression, you didn't include the root of duty ratio?
Yeah, including duty ratio, na, because of the RMS. No, you can already find the RMS value of current. Then you can directly apply. If you have a peak value, average value, that find another value. But you
So you little scroll up, sir. Can you scroll up?
Yeah, if you
One
have.
second.
Yeah. Tell me.
You scroll up, sir. The expression before the peak conduction loss you have given before this page.
Sorry, I'm not understanding what you're saying.
So can you go up a little bit slightly? The expression before this I want to see.
चालू अजून 5 जण
Okay.
What are you saying here?
Okay, sir.
It is okay?
Okay. One second. ID square. ID. Okay, sir. Okay, thank you.
Switching, this one the on and off condition. This one on condition because of current is high. And take this one current. This one 0. On time you can take like a TR, this one TR, all time or off time. So rise time. I mentioned here for finding the conduction loss, we should have a equation of this, and power is you know about the 1 by T total time period 0 to T V in I to dt. This is the expression of the power of any signal. Then here you can find also power here for TR and different at of different expression. For easy calculation, I will take like that. This is the 0 value, this one T on, and this one 0, this one T off value. Then find expression of the signal. This one is the current signal, this one is the voltage waveform. First find the voltage between them. Then you know about the line equation. Find y minus y1 is equal to y2 minus y1 divided by x2 minus x1 x minus x1. Same thing here, you can relate the y is equal to v if the and x is 10 to x is t. For the voltage, for current, y is I and x is t. Okay.
Sir, excuse me.
Yeah.
Sir, in this turn on transition,
yeah,
on this turn off transition, we have two that is a delay time and rise time we have, and similarly in this fault in this turn off transition we have settling time and fault time. Sir, in this while calculating the power loss, we are neglecting the delay time because it is same as, because the voltage and current are same as the off time values.
Yes.
That's why we are neglecting we are not calculating delay time, loss in the delay time, sir. But whereas in the settling time, during the turn off transition, in the settling time, voltage and current values are same as the on time voltage and current values. But why we are neglecting that, sir? It is purely because of the less time, or is there any other reason why we are neglecting that settling time power loss?
The state power loss is given, off state is given loss 0 already in the questions, and asking about the switching and conduction losses. For the switching is
no,
the
sir.
yeah.
No, sir. I'm talking about
delay and
during the turn off transition. That is turn off transition. We have two time labels. One is settling time, and the other one is fall time.
Yes.
We are not calculating the power loss in the settling time because why, sir? Because in settling time the voltage and current values are same as the on time voltage and current values. Then why we are neglecting the settling time? Why we are not calculating the power loss at settling time? We are neglecting that and calculating only the fall time.
I think that very less value. I think is
okay.
Delay time is very less, and the waveform is not mentioned correctly here. There, this one is the rectangular waveform or that other waveform.
Sir, in the lecture itself, sir has neglected that settling time just by saying it is approximately equal to 0.
Yeah, it's a very less.
It is, sir, whether it is purely because of the less time, that is the reason.
Yeah, this one less time and calculation also complicated for the delay time.
Okay.
It's a very less time also.
Sir, here we have to take TR and TF from the datasheet.
Yeah.
For the IRF 240.
IRF, now we given IRPF 240. Yeah.
40.
You can search a data sheet and find the TR and TF. I want to try to find a waveform, equation for the calculation of power for any signal. That's why I taken like that for TR and TF. But TR is given 0 to TR. I have taken like 0 to T on, and TF is taken 0 to T off. And find this one expression for the voltage and current. After that, calculated the power. What is the power? In this waveform, you can calculate 0. This one is a y2 value, this one is y1. Then y is a v minus y1 is a, this one value is v, and y2 is a 0 minus y1 is v divided by x2 is a t on minus 0 into t, x is t, x1 is 0, x is t, x1 is 0. This one I taken this one x1 y1, here is the x2 y2. Oh, sorry, this one is not x1, this one is the x1 and y1. For the voltage wave expression, for the current expression, take x1 y1 here, x1. Then to find voltage expression like this, v is equal to minus v by t on into t plus v is the voltage equation. Same apply for the current equation here. Take x2 dash and y2 dash. I take x1 dash and y1 dash. Same question, find I minus I1 is 0, this one, and I2 minus I1, I2 is I minus 0 divided by T on minus 0 into T minus 0, and I is equal to I is T on into T. Expression for the current. We apply for in voltage, power 1 by T, integration of 0 to T on V into Y into dt 1 by T, this one to T on. Voltage is V minus V by T on into T. Current is I divided by T on into T into dt. V into I divided by T on into T, multiply by both, V into I into T square divided by T on square. Integrate with respect to time, you find 1 by T, integration of Vi by T on into T square by 2 minus Vi T on square to T cube by 3 0 so T on. Put the value of T is T on and Vi divided by T on into T on square divided by 2. Putting value of 0, T is 0, then all of the 0, 1 by T, Vi by 2 into T on minus Vi by 3 into T on. Add this. Then you find V into I into T on divided by 6. You can also written as Vi into T on by 6 into F. You can putting time period for the frequency. This one for the T on expression, same as if you apply expression for the T off, then you find the rise time, then fall time, fall power is Vi T off divided by 6 into F. Total power is PR plus VR. T on is TR, Vi TR divided by 6 into F plus Vi into TF into F divided by 6. You find power is equal to Vi into F divided by 6 TR plus TF. The switching power. TR and TF you written from the data sheet. See.
$51 nanosecond and 36 nanosecond.
Yeah.
51 nanosecond and 36 nanosecond.
51 nanosecond. Voltage 100. Current is given 5. Frequency is 50 kilohertz divided by 6 into 51 plus 36 into 10 to the power minus 9. If you solve this, you find like 0.3625 watt, and total power loss P conduction plus switching power loss. Conduction power loss 1.8 watt plus 0.3625 watt. The total power loss. Okay.
Okay, thank you.
Next question is given referring to the previous questions with the junction temperature is given 100 degrees centigrade and ambient temperature 30 degrees centigrade. For the maximum value of junction to case thermal resistance, find out the value of case to ambient thermal resistance. Same thing is given like that. This one junction, this one case and heat sink, this one the ambient temperature. Tj is given 100 degrees centigrade and TL so given is 30 degrees centigrade. As I mentioned here, the maximum value of junction to case thermal resistance. Junction to case, this one. Thermal resistance you can find from the data sheet. RTS junction to case. You can find from data sheet. And case 2 ambient is asked about that. This one total. Know about Tj minus Ta divided by total resistance, thermal resistance, RTH Jc max plus RTH Ca is equal to power. Power we have already calculated from the question number 11, 2.1625 watt. And RTH Jc max on the data sheet. Let's see the data sheet. This one given it junction to case maximum temperature 0.883 degree centigrade. RTH Jc 83 degree centigrade per watt. Then apply here and find the value of RTCA. Tj is given 100 and 2.1625 is equal to 100 minus 30 divided by 0.83 plus RTCA. You can find 32.1 degree centigrade per watt. Okay. Next question is given a MOSFET is being operated in two different conditions, M1 and M2. Find out the ratio of the drain current in these two conditions. If the MOSFET has the gate threshold voltage given 5 volt, VTS is given, VTS is 5 volt, and gate to source voltage is given VGS1 is 10 volt, VGS2 is 8 volt. Assume the drain to source voltage VDS1 is given 6 volt and VDS2 is given 4 volt. Ratio of drain current to both condition is given, means ID1 divided by ID2 is also. We know about the ID current. First of all, checks the VGS is greater than threshold voltage or not. Then you see here VGS1 also greater than VTH. This one 10 volt, 5 volt, and VGS2 also greater than VTH. So in the first condition. Second condition, check the VDS should be greater than a VGS minus VTH. Then VDS1 greater than or are equal to VGS. VGS is VGS1, or VGS1 is given 10 volt, 10 minus 5, 6 is greater than 5, and also true. And VDS2 should be greater than VGS2 minus VTH. VDS2 4, so greater than VGS2 8 minus 5 is 3. It is 3 conditions: cutoff, triode, and saturation condition. You know about the ID current for VGS is greater than VT equal to, and VDS also greater than or equal to VGS minus VT. Then you cell, this one is the saturation region. Find ID current is half into mobility of electron into C, width of channel, length of channel, VGS minus VT square. It means you can say like the ID directly proportional to VGS minus VTH square. For finding ID1 is equal directly proportional VG1 VGS1 minus VTH1 VGS1 is given 10 minus 5 square 25. ID2 same VGS2 minus VT, IGS2 8 minus 5 is 3 square 9. Find the ratio of this one. 25 by 9. 2 point something 7.
2.77.
Yeah.
Then what's the significance of that VDS1 and drain to source voltage and is given, no? Then why these values are given? The drain to source voltage
These are given for
6 and 4.
check the MOSFET in a region, okay, saturation region or cutoff region. If cutoff region, then ID directly 0.
Okay. You can apply in the output side, you know, this KVL. VDD equal to ID1.
None
only plus VDS1.
None other parameter is given in the MOSFET, and part number also not mentioned. Then you can't apply like that. You simply find ID on the equation here.
You cannot do like that, sir?
Yeah. Because VDS is given for the checking the MOSFET in the what region? The saturation region, cutoff region, or triode region. If in the cutoff region, then that you say the ID is 0. That's not correct for flow variable.
I'm asking you can apply the KVL in the output side and then find value of I1 and I2?
Can apply here is any value not given, resistance, the value RDS also not mentioned. Then how we apply KVL? It only voltage value is given. Then now find the current from voltage.
Okay. Okay.
Two MOSFET connected in parallel to similar. I think figure is not mentioned. I draw a figure. Off your mic, please. There's some disturbance, of course. As mentioned, VDS1 is 5 volt. VDS2 we mentioned like 8 volt. That is total current is given 20 ampere. RE1 is mentioned R1 0.5 ohm and R2 is given 0.8 ohm. What is the percentage difference current sharing? It means I1 and ID1 and ID2. What is the difference between them? First equation to find like this: ID1 plus ID2 is equal to 20 ampere. Because all of total current flow is 20 ampere. And second equation we find from here. The V1 this voltage and this voltage is the same with the parallel connection. Then we written like VDS1 voltage plus ID1 into R1 is equal to VDS2 plus ID1 into R2. All of is given and find ID1 and I2 relationship. This one is 5. ID1 is not known. R1 is given 0.5 ohm. 8 plus, sorry, this one ID2. Then apply as ID1 here. ID1 is 20 minus ID2. 0.5 here. ID1 is 20 minus ID2 taken in the left side minus 0.8 ID2 is equal to 8 minus 5. You can solve this. Find ID2 5.38 ampere. Simply putting the value here ID2, then we find ID1 40.61 ampere. Percentage difference, can take difference between them ID1 minus ID2 divided by ID into 100. You can calculate this. Okay, so this is the last question.
Sir, I have one question regarding assignment 3, sir.
Okay. Ask.
Sir, shall I read it out, sir?
Okay.
A MOSFET has a gate to source capacitance of 1 nanofarad. The gate current required to sustain the turn on of MOSFET is how much milliampere if the gate source voltage is 12 volt. Sir, here only two values are given. One is gate source capacitance value and gate source voltage. So from these two value, how we can, sir, calculate the gate current, sir? It's confusing, sir, because time is not there, sir. No rise time is there, sir.
Can we
Sir, shall I read out?
Yeah. Can
a MOSFET has a gate to source capacitance of 1 nanofarad.
Yeah.
Gate to source capacitance. Gate to source 1 nanofarad.
Okay.
Now they are asking the gate current required to sustain the turn on of MOSFET is how much milliampere if the gate source voltage is 12 volt. Means gate source voltage is 12 volt, then how much gate current? So there is no time information. So if I multiply VGS and CS, then we'll get the charge, sir. But I don't know the time. So if I get the time, then dq dt, sir, then I think I will get that IG current.
Okay, I think data, some data is missing.
Yes, sir. So then how can we calculate, sir? Then it's not possible to calculate the current. Only two data is available, sir.
Sir, I think in this problem, after at the initial time, some value of current will flow. Some IG, after that, IG is 0, I think, since it is a MOSFET.
Already
IG
correct.
is 0 because
Sustain the turn. So answer should be 0.
yeah, because for sustaining the turn on of the MOSFET, I think
Sustaining the
no,
turn is given, but final once if a MOSFET already on, then it will not get any current required. Na?
Required to sustain the turn on.
It means
question is sustain the turn on.
MOSFET already on. Then you can't require a gate current, I think.
Sir, if you see the assignment 3 and question number 10, last question, assignment 3, question number 10, sir.
The
So
gate current
they
is
are asking that
gate current is required to turn on the MOSFET.
Yes, sir.
Yeah,
they are asking.
but here is the MOSFET already on. Then it will say about the sustain the current, sustain the on, turn on of the MOSFET. The MOSFET already on. Then we did not require the, I think, gate current. The gate current is 0. If a MOSFET is not on, is in off condition, that time you have required the gate current. Once the once MOSFET is on, then you did not require the gate current.
So then answer should be, sir, 0, sir?
Yeah. Should be 0.
Okay, thank you, sir.
Okay, I stop
Sir,
here.
one thing I want to ask, sir, just sir, which book we have to follow, sir, to solve this type of problems, sir? Because after all, we have to appear for that examination.
You have a Alumanand sir books already written, a book of electronics. Is it a good one? You can follow them.
Sir, I have that book, but I didn't see any this kind of problems are there, sir. That's why I'm asking, sir.
This type of problem, I think, in the gate problem, not a normal problem. You can search there.
Okay, thank you, sir. Sir, when will get this you means video link, sir?
I have sent, na? One second, I'll send.
No, sir, I didn't get, sir. I didn't get any mail from your side, sir.
Sir, yes, sir, same thing. The previous recorded session also we didn't receive, sir. Previous problem solving
Okay,
session.
Yes, sir.
okay. All right. Just a minute, wait.
So please, sir, send the link of this discussion.
I send.
Okay.
You
Thank you very much.
mailed the link.
You can check here under our chat box.
Okay, sir.
This one for the first lecture. After that, I will upload this. This one also. Okay, fine. This one link.
Yes, sir. I got the link, sir. You
okay.
meet.
Sir, I think this is for the first session.
Yeah.
Other two sessions are there, 2 and 3.
I think
Is this the same thing, sir?
They will upload it in different channels, and you should ask them. You ask them in the next classes. They provide you a channel link.
Can we ask in the forum, sir? That forum alternate.
Yeah, you can ask there also. They have provided you in later, I think.
Okay.
They provided.
Okay.
Okay, everyone. Thank you. And
thank you so much.
Good night.
Good night.